Okay, in this lesson, we're going to look at something called the normal distribution. If you're in my class, you have a study guide. If not, welcome here. If at any point in time you'd like to pause this and try some stuff on your own, you're more than welcome to. At the beginning of this, we have an actual investigation that we're going to try together. It says, with a partner or on your own, roll 2 dice 50 times. Record the sum for each roll in the frequency distribution table below, then draw a frequency polygon to do the following. So what I've done, if you have 2 dice, you might want to pause this after I've explained it to you. I've got an online dice roller here, so I'm going to roll the dice 50 times and record the sum all the time. So if I roll, I have a sum of 9. If I roll again, I have a sum of 7. If I roll again, I have a sum of 6, etc., etc. The possible sums are anywhere between 2, because that's 1 plus 1, and 12, because that's 6 plus 6. So I've done that 50 times. And what we are going to do, here's my results. If you want to pause it and try it on your own and add it into your study guide, you can do that. Here's my results, a frequency polygon. So we're going to represent the distribution of the data. Here's what I found. I rolled the sum of 2 times, 3 times, 4 I rolled 5 times, 5 I rolled 4 times, etc., etc. So I found this to be the case. And what you'll notice is this kind of represents a little bit of an arc here, or a mountain. So it appears like those middle sums, 6, 7, and 8, appear to occur the most. And what this helps me to do is introduce something called the normal distribution. If you've done this, you'll also probably notice, if you've done this, especially if you do it lots and lots and lots of times, you'll notice that those middle sums are the most frequent. So it says, based on your data and the data of groups around you, what sum do you think is the most likely to be rolled? What you will find if you do this over and over and over and over and over and over and over again, that 7 occurs the most. And the question that follows is why? And the reason for that is that there's the most possible ways to roll a 7, right? You get a 1 and a 6, or a 2 and a 5, or a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. Whereas in order to roll a 2, there's only one possible combination, which is a 1 and a 1. So that and 12 will be the most infrequent. So that helps us to introduce kind of what normal distribution is. What normal distribution is, and it kind of looks a little bit like what we have here. As you can see, it kind of looks like a mountain in a sense, or there's other ways to describe it. But if you use a lot of data, and this generally has to do with usually any type of living data, so let's say weight, height, IQ, various things. If we were to distribute this and take lots of data on it, it's data that results in a symmetrical distribution about the mean, and it's also called the bell curve. So what you'll find, whether you're measuring weight, height, IQ, all those different living type of things, letter grades for example, is that most people fall close to the mean in the middle here, and then it slowly tapers off. So there's less and less and less people who are way above the mean, whether they're really smart or really overweight, etc. And there's also less and less and less people way below the mean, whether they are underweight or they have a low IQ, etc., etc. So most data falls within a normal distribution like this. We'll be investigating the percents that are inside this data shortly. I'll give you an idea about it, but I think when we get practical, it's going to make more sense. So that's what a normal distribution curve sort of looks like. The characteristics are as follows. First of all, the graph is symmetrical and shaped like a bell. We investigated something called standard deviation in the previous lesson. You might want to look at the 5.3 lesson for that. But here's what we find about normal distributions. We find that approximately 68% of the data is within 1 standard deviation of the mean. So that's here. So if I go 1 standard deviation to the right or to the left, 68% of data is within one standard deviation of the mean. What we also find is that there's approximately 95% of data within 2 standard deviations of the mean. So if I go 2 standard deviations, and this will be explained more thoroughly in a bit, 95% of data falls within that. And finally, if we were to go 3 standard deviations from the mean in either direction, 99.7%, almost 100% of data falls within 3 standard deviations of the mean. So what we're going to do is apply some of this knowledge to a couple problems. First of all, we're just going to examine to see when things are normally distributed. Example number 1, so we're in part C, examining the normal distribution. There's 3 examples here, and it just says, is the data in each set normally distributed? We've got intervals here, so I don't know what data this is collecting, but this will get you a sense of what normal distribution may look like. Interval between 1 and 4, 5 and 8, 9 and 12, 13, 16, and we have the frequencies. So if I was to graph this, which you don't have in your study guide, but if I was to graph this, 1 and 4 happens 3 times, 5 and 8 roughly 9, 9 to 12 is roughly 18 times, 13 to 16 is roughly 15 times, 17 to 20, 11 times, and 21 to 24 roughly 2 times. So if you kind of look here, what this might look like a little bit, it's not a lot of data, but this data does, so is it normally distributed? Yes, it does appear to be somewhat symmetrical and also a little bit like a bell curve. You'll see a counterexample in the next one here. So example 2 has these intervals and then these frequencies. So if you look at the frequencies here, I don't have the intervals or frequencies written here, but what you'll notice is that a frequency of 7 in your first interval would be roughly here, 3 is down here, 8 is up here, 10 is roughly up here, 12 is here, and 9 is here. Now if I was to kind of look at the distribution here, this neither appears symmetrical or like a bell curve whatsoever. So that would not be normally distributed. And this last one says this: if we have these frequencies, the first interval has a frequency of 1, which is low, and then 3, 4, 7, 28, and 8 would look roughly like this. Although this does go up, 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 and then down, so it sort of has bell-like shape, it does not appear symmetrical whatsoever. So the answer to this would be no, it's not normally distributed. So that's kind of an introduction to things that would appear to be normally distributed. Let's do one example. Example number 2 says this: IQ, intelligence quotient, you may have heard of it, is normally distributed. So we're stating that it is a normal distribution. Most people fall close to the mean, less people are further above the mean or below the mean. And it has a mean of 100 and a standard deviation of 15. So if I was to look at this, a mean of 100 means that right in the middle here, I would put the number 100, and a standard deviation of 15 means this, that in either direction, as I go up a standard deviation, I would add 15. As I go down standard deviation, I would subtract 15. So every standard deviation, I'm jumping by a value of 15. This is just something they have calculated by taking a lot of data. Okay, so here is kind of the labels on each standard deviation. Another thing that I'll add here is, as we've talked about, there's 99.7% within 3 standard deviations. So the remaining 2 small parts, if we subtract that from 100% and divide it by 2, you'll have that these 2 small parts here are 0.15%. That might help us answer some questions in a little bit. So we're going to answer 3 questions. First question says, what percent of people have an IQ between 85 and 115? So if you look here, between 85 and 115 is the people between here. So that would be this group of people. And if you look at the numbers or the values in there, here's a 34 and here's a 34. So that would be 34% plus 34%. Or in other words, 1 standard deviation either direction. The answer to that would be 68%. So 68% of people have an IQ between 85 and 115. The next question says this: what percent of people have an IQ between 55 and 130? So if you look at where 55 is, I'll do this question in purple. 55 is right here. 130 is right here. So what percent of people are contained between that? So that would be all of these people right here. And if we add those up, we have 2.35%, we have 13.5, 34, 34, and another 13.5%. And that would be a total of 97.35%. So 97.35% have an IQ between 55 and 130. And the last question in this particular lesson says this: what percent of people, and you might want to pause this if you'd like to and look at the answers in a little bit. It says, what percent of people have an IQ above 115? So maybe try that on your own if you'd like to. All right, the percent of people that have an IQ above 115, if you finish that off, here's an IQ of 115 right here. So above that IQ would be this combination of people. So that would be 13.5% of people, plus 2.35% of people, plus 0.15% of people. So that's a total of 16% of people have an IQ above 115.